white light is nothing but a combination of different colors, right? We say it is 7 colors just for our human eye, but then there are like infinite number of continuous band of wavelengths, right? So all these wavelengths are going to get bent at different angles, and that is why you are seeing different things coming at different angles. That is what we call it as dispersion of white light. Okay, so make a note. Dispersion of white light is nothing but when white light passes through prism, different wavelengths contained in the white light. When white light passes through prism, different wavelengths contained in the white light gets bent at different angles. So different wavelengths will have different refractive index. We'll talk about that later. So different wavelengths will get bent differently. So because of that, you will see the Whipjier pattern. This is what is called dispersion of white light. So we have an important derivation here, okay? It's like an extremely important derivation, so make sure you study this properly. Of course, every derivation is important, okay? So if I had a prism like this, if I had the light passing like this, so please listen carefully as I say. It's very easy if you go step by step. So look at this. What is that? Normal, okay? So rarer to denser. So towards the normal or away from the normal? Towards the normal. So instead of going straight like this, it's going to go towards the normal. So it will go something like this. Instead of going like this, it will go like this. And what is that? What is that? Again, normal for this surface. Denser to rarer. So instead of going this way, what will happen? It will go away from the normal. So normal is this way. So instead of going this way, it will go this way. So that's what I was showing in the green laser light. So when you send the light this way, it will be coming this way. It's not going to go this way. That means it will go like this. So if I extend this dot and this dot, right? It's a very happy mood. You know how I got these lines? So this is angle of incidence I. Okay. This we call it as angle of emergence E. This is angle of the prism A. This is refraction R1. This we are going to call it as R2. So if I extend this line over here, right? So this light was supposed to go straight like this. But what has happened? Just got bent 2 times, and then if I extend this line over here, right? So this angle, so please listen carefully. So this is the incident ray direction and this is my emergent ray direction. So this angle we call it as deviation, angle of deviation. So that is how it has been deviated totally. So as usual, it's all trigonometry, right? If you know trigonometry, you can derive this. So look at this quadrilateral here. So this, okay. So if I see this is my A. So what can you say about this angle here? This and this. This is a surface, this is a normal, so that means this must be 90-degree right angle. Okay. Even though it's very easy, it's hard for you to recognize that. So if this is 90, this is 90, this is A, what can you say about this one? So if I add the 4 angles of a quadrilateral, I should get 360 degrees, which means 180 is already gone, which means this must be 180 minus A. Okay. So that is this angle. So now look at this triangle. So I am going to, from this I can say this is R1, this is R2, right? Recalling which triangle I am talking about, this triangle. And from this I found that this is 180 minus A. Right? So what can you say about the relationship between these three? This plus this plus this is equal to 180. So that means R1 plus R2 plus 180 minus A is equal to 180. 180, 180 cancels. So I will get A is equal to R1 plus R2. Okay. Not able to see it. So now we have to go to the other triangle. So look at this. So first we looked at this triangle, then we have to look at this triangle. So this triangle, if I see it, what can you say about this angle? 90 minus R1 will give me this angle. I want this between this line and this line. Sorry, this and this. I minus R1, right? Because this is I, means this is also I. Right? I minus R1. So this will be I minus R1. And similarly, this will be E minus R2. And this we said it is del, angle of deviation. What can you say about the relationship between these three things? Okay, very good. So external angle is equal to sum of the two internal angles. So del is equal to okay, that's a simple trigonometric theorem in our triangles. So if I want which one? Total angles? No, total sum of all the angles is 180. Triangle. How can it be 90? You take a 90-degree angle, if this itself is 90 degree, right? This 180. So del is equal to I plus E. So I am going to write this as I plus E minus R1 plus R2. But what is R1 plus R2? A. So I can say I plus E minus A is my del. Okay. As I always say, from the diagram you have to come up with these things, you have to remember this. But when it comes to the derivation, you have to remember what is the starting point. So the starting point is sin I by sin R is equal to refractive index. So okay, we have a couple of minutes, so let's quickly finish this. It's kind of easy. But then there is a small experimental concept which cannot be understood without doing the experiment. So what they are saying is, suppose if I keep on increasing the angle of incidence, right? Remember I had this laser and I kept on changing the angle of incidence, right? So as you keep on changing the angle of incidence, the angle of deviation, right? As I keep on increasing the angle of incidence, the angle of deviation will reduce. But then after a certain point, it will start increasing. Okay. This, how did they get it? Only by doing experiment. Okay, so without doing experiment, it's not possible for us to understand this. So this one alone you have to say that okay, this is coming from the experimental results. So we call this particular point is your del minimum deviation. And when you achieve this del minimum, and del minimum happens, we say that I will be equal to E. So this will be equal to this line will be parallel to this, and then R1 will be equal to R2. So many things will happen. R1 is equal to R2, and then it will be, this line will be parallel to this. So this line and this line is parallel, right? So the refracted ray and the base of the prism will be parallel. Refracted ray and base of prism. So take it down as experimental result. Experimental result. So that means A is equal to R1 plus R2. I can say it is 2R. Del is equal to I plus E minus A. So I said I and E are same, so that means I can write as 2I minus A. R is equal to A by 2. I want to find, so I told you my intention is to make sin I by sin R. Refractive index of the prism I want to find. That means I can be found as del by A divided by 2 is my I. So that means if I did sin I, I'm going to erase this prism. I need some space here. This is okay. So if you have not taken it down, quickly take it down. This line and this line are parallel. So after this, it's your usual stuff. Sin I by sin R is equal to refractive index M21. So sin, we call it as del M here because we are putting these conditions, right? Del minimum, so del M. So sin del M plus A by 2 divided by sin A by 2 is equal to refractive index M21 for the prism. So this is the derivation for prism refractive index. So how to find the refractive index of a given prism? If I did this experiment, if I know the angle of prism and if I found the del minimum, I can calculate the refractive index. But there is a special case. So we'll finish this. So special cases. There are something called small angle prism. Okay, I don't know if I have something to show you quickly. See that? From this side, if you see, it looks like a glass plate. That's actually a prism. Okay, so this is called a small angle prism. So the angle here is very, very small, something like less than 5 degrees. Okay, so these many times you'll be using these kind of things in the experiment. Okay, so since the angle is very, very small, what do you know? Sin theta is equal to theta, right? That means you can approximate it, and so this is what is called small angle prism. Okay, we'll try to do something later with this. So after that, do that yourself. Sin theta becomes theta, which means sin goes away. 2 cancels. Del m plus a divided by a is equal to n. So a goes on the other side. So a into n. Then the other a also goes on the other side. So minus a. So try that yourself quickly. So for small angle prism. So take down this small angle prism. A is less than 5 degree. So in your problems, if it says small angle prism, you can use the formula directly without using this one. So that means I can say sin theta is equal to theta. So this values are going to be very small. So we say del m plus a by 2 divided by a by 2 is equal to n. So 2 cancels, a goes on the other side. So since we are talking about the refractive index of the prism, we can directly write it as n with respect to the r. A is equal to n a. So if I take the n a on the other side, del m is equal to n a minus 1. So refractive index, did I make a mistake there? A comes out, so that means, yeah. So A comes out commonly, so I'll get n21 minus 1. Is that right? So that's all. So I'll stop here.